Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a special edition of this series focused on spooky software development. Think about it as a Halloween edition of Think Design Work Smart. Now, before we start, I have to make a confession. I dislike Halloween. I don't like anything about it. I did not grow up with it. I don't understand why it's so interesting, other than, of course, growing up with it and finding it interesting. I don't like the costumes. I don't understand why you need another reason to eat a lot of candy. And most of all, I hate Halloween TV specials, special episodes in the series that I watch. I'm not very big either on horror movies. I like a few, but most of them I find just not scary and kind of not interesting. I watch them from time to time, but I can't say many of them have actually been impactful in any way. So maybe you're wondering why a Halloween edition. Well, this year is a bit special because maybe you notice that one of my lights doesn't work, and that's because one of the studio lights decided to blew up a fuse and trip the main circuit breaker as well, which was interesting. And now I'm searching for a replacement fuse and to figure out whether this was temporary or what happened with it. But it was kind of a small boom, and then the whole power went down. And it was interesting, to say the least. So then I said, look, one thing that I can say about software development is that software development is kind of scary. It's always been scary. And if you stop and think a little bit about it, about the fact that code controls a lot of the things around us, it's not a very easy feeling, especially when you know how that code is written, when you know the challenges that people have to write code that works, first of all, that has fewer bugs, that is clean and allows developers to fix easily, to avoid issues, and so on. So because of that, I said, okay, I have a collection of things that I like to talk about regarding spooky software development, and I also asked my colleagues. And my colleagues came up with a list that I found very interesting. And the structure for this video will be, first we'll go through this list of things, and maybe you'll think about some ideas from your own experience, and you can post some comments regarding each of these. And in the second part, I'm gonna tell you about 5 of the spooky things of software development, or things that I find spooky. Some of them are very interesting bugs, and some of them are some scary developments. So that's it. That's in it for today. That's what we'll do. Right. First, I asked my colleagues, and I got a number of replies, and they are quite funny. Haunted code-based legacy systems that refuse to die. I mean, yeah, maybe you know about some legacy systems. Now, what would make them haunted? Things that happen that are not easily explicable. Maybe undeterministic behavior. Who knows? Let me know if you have any examples. I'd like to hear about those in comments. creepy AI. I think there's a lot of it around us right now. Just this morning, I was wondering, can you ask ChatGPT, how would you kill humans or something like that, and see what the answer is? I assume they have some guardrails around this, but there's always a way of getting around guardrails with AI, which is telling the asking it to imagine writing a story about a specific thing. And okay, I don't want to try this, but if anyone wants to try some creepy AI stuff, let us know. Let's get scared together. The curse of documentation when there is none. I think this is more often than not. Is there ever good documentation? But on the other hand, have you worked with a project that had no documentation? I think even worse is when you have a project that has misleading documentation. Like you read something, it's supposed to be, and then you work on that basis and it turns out that it's completely wrong and it's not what it says. Okay. Zombie bugs, errors that once stay fixed. I like this one. Yeah, I think there are some bugs, and we talked a little bit last week, I think, when we talked about ways to prevent bugs. Bugs will tend to come back, and particularly when you have something like you copy something from Stack Overflow or ChatGPT, you adapt it and to solve a problem, and then your colleague does either the same or copies from the code and changes a little bit and so on. And then this thing spreads in hundreds of places maybe, and then you get a bug that is in the core. And then you fix that bug, but it keeps coming back and popping up in different places. As we said, bugs tend to cluster, so there's usually one source for multiple bugs. And in this case, the practice would be try not to copy paste as much, Coder ghost, programmers that leave unexpectedly and leave a void behind, they are nowhere to be found. Now, I'm gonna talk a little bit. One of my 5 top things is about this, or related to this. It's not necessarily about programmers leaving unexpectedly, but about us working with code where you have no knowledge. So it's kind of coder ghost. Yeah, maybe it's the ghost of the programmers. The haunted API, abandoned, forgotten, but still used APIs that are not maintained and deprecate without warning. Have you used any of those? That's always a thing that bothers me in software development, and maybe one of the things that scares me is the list of dependencies that goes on and on and on, and it's very hard to figure out what actually works and what doesn't. And particularly if you talk about security, what's secure, what doesn't, what's not. And we know everything is insecure to a certain level, but the question is, when you have hundreds of dependencies that depend on other hundreds of things, how do you know? I'm looking at you, NPM. Ghosts of the web, defunct tech, and the haunting side that refuse to die. And I also got some examples. Flash. Are there still Flash websites out there? I think they are not supported anymore, but maybe there are a few left that just don't work. VS Script, I have no idea what this is about, but apparently there was something called VS Script. CGI/Perl. Okay. I think this is definitely still around. Silverlight. Oh, yeah. Remember when Microsoft tried to replace Flash with something of their own? And they created this Silverlight technology, which was retired after, I don't know, 4 years, 5 years. It had a pretty short time lifespan. Shockwave. Shockwave in my mind goes together with Flash. It's kind of at the same time. And I think it was a similar goal. ActiveX controls. Okay, ActiveX. You might not remember, but there was one point where ActiveX was the only way to have things, dynamic things running in browsers. Java applets. And applets were the second, the improvement. Real player plugins. Oh gosh. Yeah, real player. So there was a time when real player was the only way you could play video on internet, or well, that and Flash at some point. And yeah, I think neither were very secure, but hey. Microsoft front page extensions. Front page, yeah. Creating websites with front page, and I think there was another one, Adobe something. Which was, there was a Macromedia tool that was bought by Adobe, but I don't remember the name. And you could create websites in it, but the HTML was awful. Iframes. Now, iframes still have their use. We know they have a lot of problems, particularly security problems, but they have their niche. So as long as you use the security headers, if I remember correctly, to activate the right iframes, and only from certain sources, then yeah, it's good. Otherwise, people can load stuff into your iframes, and that's not great. QuickTime plugins and Netscape plugins. Netscape plugins, are they still there? Okay. So these are some ideas. And if you have any examples from any of those, I'd like to hear them. But now let's look at my top 5 spookiest things in software development. Number 5 is the coder ghost, programming and testing without knowledge. So let me tell you a story. We were once called in an organization to help with the agile transformation, but part of it was also technical stuff. And so once we set up teams and did all that, what we did was, okay, so let's look at automating testing, and let's look at the software development model, how are programmers working and so on. And it turns out that the code base was very old. It was created by a team. The project was then took over in, how would you call this? So basically a hostile takeover of the project, which meant that the original team was no longer involved at all. And the people who worked on the subsequent iterations of the project had no idea of the initial, so they didn't have the knowledge of the original team. And they kept developing for a while, but then what happened is that some of these people left. And when we got there, we had one person in the team who was kind of the third generation of programmers. So basically she learned from the people who learned from the people who learned from the people who who took over initially. And she was the only one who still had some knowledge about that project. And the way software development worked was they would get some requirements, and programmers would go to this person and start asking questions, and the answer was usually, okay, you have to go in that file, change that function, you have to go then in that class, change that function, and so on. So very, very granular steps. And then when I tried to work with a tester in order to automate tests, and the first question was, okay, so how do you test? Well, I introduce some data, and then I look at the output, and I think, it looks about right. And that was the testing. And this is when I realized, oh boy, programming without having any knowledge about what you're doing is not only incredibly uninteresting, boring, also incredibly slow and annoying. But also, one of the toughest things here is it's almost impossible to recover. How do you recover from something like this? I mean, I know the only way to do that is to invest a lot of energy. On one hand, write a lot of automated tests just to discover what's going on in the code. On the other hand, write documentation that combined with the tests will give you a better view. But this is something that can take years for a project that large. And who wants to invest in this instead of trying to add requirements, even at a very slow pace? So yeah, Ghost is not really a coder ghost, it's more like a project ghost. This was my number 5. Number 4, very interesting bugs. Back in 2022, an article written by Raymond Chen on the Microsoft developer blog posts. Janet Jackson had the power to crash laptop computers. A colleague of mine shared a story from Windows XP product support. A major computer manufacturer discovered that playing the music video for Janet Jackson's Rhythm Nation would crash certain models of laptops. I would not have wanted to be in the laboratory that they must have set up to investigate this problem, not an artistic judgment. One discovery during the investigation is that playing the music video also crashed some of their competitors' laptops. So what was going on? And then they discover something extremely weird. Playing the music video on one laptop caused the laptop sitting nearby to crash, even though that other laptop wasn't playing the video. Imagine investigating this. What's going on? It turns out that the song contained one of the natural resonant frequencies for the model of 5,400 RPM laptop hard drives that they and other manufacturers used. So basically what this was doing is that it was the music was resonating with hard drives that were close enough in the proximity and crashing the laptop because the drive will start to wobble. It's good that it didn't get destroyed by the music. The manufacturer worked around the problem by adding a custom filter in the audio pipeline that detected and removed the offending frequencies during audio playback. Imagine writing a custom audio filter to remove the frequencies that crash hard drives around you. And I'm sure they put a digital version of a do not remove sticker on that audio filter, though I'm worried that in the many years since the workaround was added, nobody remembers why it's here. Hopefully their laptops are not still carrying this audio filter to protect against damage to a model of hard drive they are no longer using. I like this bug. It's a very fun bug. Yeah. So music can crash PCs. Now, no longer the case because we are using SSD drives and they don't have any mechanical parts. They are not things that are moving. So probably the resonant frequencies don't apply, or if there are, well, you could probably blow up SSD hard drive with the appropriate resonant frequencies, but I assume those are not in any music. Interesting, right? So this was number 4, a music bug, a spooky music bug. Number 3, when iPhones got disabled in a hospital, well, in a medical facility. October 30, 2018, 5:20 p.m. article written by Daniel Oberhaus on Vice. An IT worker at a medical facility made the remarkable discovery about iPhones and Apple Watches earlier this month, after a freshly installed MRI machine appeared to disable every iOS device in the hospital. As detailed in a post on the rsysadmin subreddit, Eric Woolridge, a system administrator at Morris Hospital in Illinois, was flooded with calls on October 8 after several iPhones owned by hospital employees all stopped working for no discernible reason. At the time, the hospital was having a new MRI machine installed, which is used for making high-resolution scans of the brain. Now, MRIs work by producing a very strong magnetic field, so Woolridge initially assumed that the phones were disabled by an electromagnetic pulse generated by the machine. There was just a problem. An EMP would have disabled all electronic devices, not just iPhones. Yet when Woolridge did a tour of the facility, he discovered the issue was isolated to about 40 Apple phones, tablets, and watches. Android phones were just fine, as was the rest of the computer equipment at the facility. Now imagine having to investigate this bug. According to Woolridge, most of the Apple devices in the facility seemed completely dead. Many wouldn't give any indication of charging when plugged into the wall and had issues connected to the cellular network, but not the Wi-Fi. And now, what happened? As Woolridge later discovered, the MRI installation involves supercooling the giant magnet in the machine by boiling off liquid helium. This evaporated helium is usually pumped out in the facility through a vent, but this vent was leaking the helium into the rest of the facility. In all, about 120 liters of helium, or about 90,000 cubic meters in its gaseous state, was pumped out of the MRI room, and an untold amount leaked into the rest of the hospital. Woolridge ran some tests of his own to see if helium could shut down an iPhone. He placed an iPhone 8 Plus in a sealed bag and added some helium. In a video of the test, Woolridge runs a stopwatch up on the phone. The stopwatch increasingly speeds up during the course of the video before the iPhone freezes at around 8 minutes. The helium, it seemed, was messing with the iPhone's clock. So imagine having to solve this bug. As detailed in the blog post by the Right to Repair organization iFixit, helium atoms can wreak havoc on MEMS silicon chips. MEMS are microelectromechanical systems that are used for gyroscopes and accelerometers in phones, and helium atoms are small enough to mess up the way these systems function. Yet both Android and iPhone and Apple phones use MEMS silicon for their devices, so why were only Apple phones affected? The answer, it seems, is because Apple recently defected from traditional quartz-based clocks in its phones in favor of clocks that are also made of MEMS silicon. Given that clocks are the most critical device in any computer and are necessary to make the CPU function, the disruption with helium atoms is enough to crash the device. In this case, the leaking helium from the MRI machine infiltrating the iPhones like a tiny grain of sand and caused the MEMS clock to go haywire. This isn't news to Apple, however, which explicitly mentions that exposing iPhone to environments having high concentration of industrial chemicals, including near evaporating liquefied gases such as helium, may damage or impair iPhone functionality in the phone's manual. You see, we don't often think about the environments in which our devices are running, but they can bring to some spooky bugs. And this was number 3. Now, number two is a very scary one. It's an old one, but it is very scary. Stanislav Petrov, if you don't know this name, this guy, he saved us from a nuclear mutual assured destruction. On 26 September 1983, during the Cold War, the Soviet nuclear early warning system reported the launch of one intercontinental ballistic missile with 4 more missiles behind it from the United States. These missile attack warnings were suspected to be false alarms by Stanislav Petrov, an engineer of the Soviet Air Defense Forces on duty at the command center of the early warning system. He decided to wait for corroborating evidence, which none arrived, rather than, so this is the critical thing. This guy had about, I don't remember exactly, but it was a matter of seconds, 90 seconds, something like that. He had to decide whether to wait for more information or the alternative, immediately relaying the warning up the chain of command. This decision is seen as having prevented a retaliatory nuclear strike against the US and its NATO allies, which would likely have resulted in a full-scale nuclear war. Investigations of the satellite warning system later on determined that the system had indeed malfunctioned. So imagine being the officer on duty in a bunker. Let's read this because this is incredible. On 26 September 1983, Stanislav Petrov, lieutenant colonel in the Soviet Air Defense Forces, was the officer on duty at the Serpukhov 15 bunker near Moscow, which housed the command center of the Soviet early warning satellites, codenamed Oko. Petrov's responsibilities included observing the satellite early warning network and notifying his superiors of any impending nuclear missile attack against the Soviet Union. If notifications was received from the early warning system that inbound missiles had been detected, the Soviet Union strategy was in immediate and compulsory, so not only immediate but also compulsory, nuclear counterattack against the United States, specified in the doctrine of mutual assured destruction. Shortly after midnight, the bunker computers, it was after midnight, great, reported that one intercontinental ballistic missile was heading towards the Soviet Union from the United States. Petrov considered the detection a computer error, since a first strike nuclear attack by the US was likely to involve hundreds of simultaneous missile launches in order to disable any Soviet means of a counterattack. Furthermore, the satellite system's reliability had been questioned in the past. Petrov dismissed the warning as a false alarm. The accounts of the event differ as to whether he notified his superiors or not, after he concluded that the computer detections were false and that no missile has been launched. Petrov's suspicion that the warning system was malfunctioning was confirmed when no missile arrived. Later, the computers identified 4 additional missiles in the air, all directed towards the Soviet Union. Petrov suspected that the computer system was malfunctioning again, despite having no direct means to confirm this. The Soviet Union's land radar was incapable of detecting missiles beyond the horizon. And now, this is what I like. What was the source of this problem? It was subsequently determined that the false alarms were caused by a rare alignment of sunlight on high-altitude clouds and the satellite's Molniya orbits, an error later corrected by cross-referencing a geostationary satellite. So basically, the clouds were reflecting light, and this triggered a false alarm of a nuclear launch. And we were maybe 90 seconds from complete destruction. And this guy had to make the decision to say, you know, maybe it's not what it seems. Honestly, this is scary. And now imagine having these systems automated even more nowadays. Spooky, right? Now, you may wonder what is worse than nuclear war. Well, number one on this list, which is ransomware as a service. So maybe you've heard about ransomware. I'm sure you did. Ransomware is a type of cyber attack that involves getting into the systems of an organization, encrypting all the data, and then asking for a ransom to decrypt, to provide the decryption method and key and so on. Okay, and this is one of the attacks that is stopping and crippling a lot of hospitals, I think banks, I think, if I remember correctly, Sony was a target, but mostly, recently, it's mostly hospitals and government organizations. I think only I think it was this week, one of the websites of one of the mayorships from Bucharest. Bucharest is split into 6 sectors, and the 5th sector has its own mayor, its own website, and it got attacked by one of these attacks. So, yeah. And now, these are already bad, but what's worse is that now there's a whole ecosystem supporting this. Ransomware as a service is a business model for criminal enterprises that allows anyone to sign up and use tools for conducting ransomware attacks. Like other as a service models such as software as a service or platform as a service, ransomware as a service customers rent ransomware services rather than owning them as in a traditional software distribution model. Ransomware is malware that locks up a victim's systems or files, usually via encryption. The victim is only able to regain access to their data once they pay a ransom to the parties behind the ransomware attack. Ransomware has become a major industry in the criminal underworld worth billions of dollars a year. While many imagine that the people behind cyber attacks like ransomware are highly skilled programmers, many attackers do not write their own code and may not even know how to do so. Cyber criminals with coding skills often sell or rent out the exploits they develop instead of using them themselves. Ransomware is just one area of the crime industry with a as-a-service model. Attackers can also rent distributed denial of service tools, subscribe to lists of stolen credentials, hire botnets, or rent banking trojans, among other services. How does ransomware as a service work? RaaS services use a number of different revenue models. Providers may charge a flat rate, monthly subscription, take a percentage of their customers' profits, use a hybrid of these two models, or charge a one-time licensing fee. Once a RaaS customer creates an account and makes their first payment, usually in Bitcoin, they can select the type of malware they would like to use. After payment has been completed, attackers begin their campaign of distributing the malware and infecting victims. Most often, ransomware attackers use phishing or social engineering campaigns to try to trick users into executing the malware. These methods are fairly cheap compared to purchasing a zero-day exploit or access to a backdoor. Once the malware executes, the victim's computer becomes encrypted and unusable, and the attacker displays a message with the instructions on where to send the ransom. And now this is the thing that makes me even... Okay, it's... Read this. RAS providers often offer 24/7 customer support for attackers who get stuck or cannot get their malware to work properly. Most providers have community forums where customers can ask questions and exchange ideas. Many also offer step-by-step guides for how to execute a ransomware attack with their tools. So, yeah. If you imagine that people need to be highly skilled to run attacks, no. You need to have some bitcoins, subscribe to a service, you get 24/7 support. They will help you to run your attack. I mean, it's a serious organization, right? Oh my God. Now you understand why I find this the spookiest one on this list. All right. So, Halloween edition of Think Design Work Smart. I hope you had some good time, spooky time. I don't know, whatever you prefer. Maybe you learned something interesting. I really hope so. And please share with us if there are any other spooky things related to software developments. Let's get scared together at least. We love comments, so let us know in the comments. What do you think about this? Have you learned anything new? Are there other examples that you find interesting? And yeah, let's talk some spooky software development. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.